Hi, everybody. Thanks for coming out tonight. We are the Penn State Technology Club, and our guest tonight is Patrick Laverty, and he will be talking about passwords. I know your password, and he is a penetration tester for Rapid7 and also the creator and organizer of the Layer 8 conference. Thanks for coming, Patrick. Yeah, you're muted.
I always do that. Awesome. Thanks for coming. All right, let's see. Share my screen here. Host disabled attendee screen sharing. Is it possible for you to add that?
Yeah, 1 second. How's that? Are you able to now?
Say, share screen. Yes. Desktop 2. Share. All right. So that's all good. You can see the slides now?
Yep, looks good.
Cool. All right. And let's just go into the presentation mode for now. All right. So thanks everybody for coming. I called this, I Know Your Password, only because through some of the research that we do and some of the experience that we have with these types of things, we're often able to figure out people's passwords. So I might not exactly know yours, but if I were to do a test inside of a company network, chances are we're probably going to be able to guess some people's passwords inside of there as well. And then by the time that we're done tonight, you'll certainly be able to do the same thing as well. So for the first thing, the who am I, Ray kind of mentioned, penetration tester for Rapid7. I do work and live in Rhode Island, so just a little ways up the road from Penn State. She mentioned that I run the Layer 8 conference and DEF CON 401, where Monday night, gonna have a very special guest where, let's see if I end my show and then pull in, let's see this thing here. So the very special guest Monday night for DEF CON 401, we're going to have Ray Baker, who's an expert in open source intelligence, talking about OSINT tools. So that's also open to anybody. Anybody can go on to meetup.com/DEFCON401 and sign up for that if that's something that you want to do. Just like she mentioned, also run the Layer 8 conference coming up June 6th. That's also all virtual online, so anybody anywhere can do that. And then also with the Layer 8 conference, we do have a podcast where we have had another awesome guest. Ray has been on that as well, way back in episode 9. This week we released episode 25. So there's been a whole bunch of them there, a whole bunch of content. And if you're not familiar with the Layer 8 conference, we focus on social engineering and OSINT. So that's really what the whole conference is about. That's what the podcast episodes are all about. So if that's something that interests you, please check that out. Back to the slides. All right. And let's see, I also crack passwords for fun as part of my research. I know I should probably get a better hobby, but it's kind of what I like to do. One of the way that I often get to do it, and I know some of my Rapid7 teammates are on the line as well, so they've probably done this, where I have told the team that if you want help with cracking passwords, then just give me your hashes and I will do that for you. So that's one of the things that I often enjoy doing. And that's how I've also been able to develop the research that led to this presentation as well. Just a heads up for you, Ray, both of my screens filled up. So, oh yeah, there isn't a chat anyway, but if anybody just wants to jump in and ask questions, feel free. I think there's like raise your hand button in Zoom or something like that. I can't see it. So if you have a question or anything like that, you'll just have to jump in and speak up. That's the only way that I can know that there aren't any questions until I'm completely done, just to give the heads up about that. All right. So some guidelines with this. All the hashes that we are going to look at and all the research that I've done and all the statistics that we have are all going to be of type NTLM. There's lots of different hash types out there, and there's really not a whole lot of difference among them other than how strong they are and how much time that it actually takes to crack those types of hashes. But the process for a hash cracking is all going to be about the same, and we're going to be talking about that as well. All the data that you see here, these were all taken from real production Active Directory instances. So yeah, we're gonna talk about that as well. I do my cracking using word lists that include the 95 available characters on a typical US keyboard. I have had people come up to me and say, well, what if I put a character that isn't on the keyboard in my password? Will you be able to get that? And chances are no. Which then leads to the next question then, well, why don't people just use, let's say all Chinese characters for their password? And it's like, yeah, that would be great. That would make password cracking a whole lot harder. Mostly because we do this against word lists. And if we're not going to have those characters in our word list, then we're not going to find them. And one problem with people using those other characters in their passwords is unless you've set up your keyboard correctly or in a way to be able to just quickly type in those characters, it generally is going to require 4 keystrokes in order to type one of those characters. So we know that most password policies are going to be a minimum of probably 8 characters. So if you're going to put in like 8 characters that are not on the keyboard, that requires 32 keystrokes. And if you're going to use 32 keystrokes for your password, well, then you might as well just go ahead and create a 32 character password that's on the keyboard, or even something shorter. Once things start getting over 14, 15 characters, they get a lot harder to crack. So I would think 32 keystrokes is going to be a little bit of an overkill with that. And that your mileage may vary with the other types of password hashes. The research that I did in here just used NTLM. Some crack faster and some crack a lot slower. And we'll see some of those in here as well. What are you talking about? Well, what we're going to be talking about in this presentation. We are going to be cracking some real active password hashes. Like I said, that these come from actual Active Directory instances. They come from customers that myself and other people on my team have extracted from domain controllers. We make sure that there's no information in there that's going to indicate who the customers are, where any of these passwords come from, and a lot of it is just anonymized into statistics. I think a lot of the information that you see that is based on the data that came from those Active Directory instances is really just going to be consolidated and anonymized data. Anything that's going to have actual passwords and hashes in this presentation, those are going to be things that I made up and that are going to be fake as well. We'll talk about how strong the passwords are that we see inside of these Active Directory instances. We'll take a look at some of the password policy effectiveness, some of the very commonly seen ones, some patterns that we can often use to crack additional ones. We'll see just some basics in terms of the methodology that I often will use in order to crack the passwords. And coming away from this tonight, you should be able to do this yourself. So often that leads to the kind of realization that like these things are real. And yes, the data that I got this from is from my penetration test, other people on my work team that have extracted these hashes from the Active Directory instances. And the way that they do this is it's usually going to be through an internal network penetration test where we eventually escalate our privileges to that of what a domain administrator can do, or some level of privilege where we are an administrator on a domain controller. And what we are then doing is going to be extracting the NTDS file, because the NTDS file on a domain controller is where all of these domain hashes are going to exist. Another thing that I do like to do is to extract the password policy out of there as well. Pulling out the password policy does help a little bit with the password cracking to know at least what like the minimum length is going to be. It makes no sense to try to crack passwords with a 6-character word list if the minimum length is going to be 8, or if there's a 14 minimum character length, then obviously any words that are only 8 characters long are not going to be helping. So that's one reason that I like to pull up the password policy as well, to get an idea of at least what the minimums are going to look like. All right, so once we pull out that NTDS file from a domain controller, what does that look like? Well, the tool that I like to use is called CrackMapExec, which is a free tool on GitHub and anybody can use it. So this is what it looks like when you pull out the NTDS, which is going to be that whole database of password hashes for the domain. It's kind of a mess. There's a lot of stuff there, and we don't really even care about all of it. Like I mentioned earlier, since we are now showing exact real hashes, these are all made up. I would get fired if I was showing customer information here, which you'll kind of get an idea just from the names and things that you see about how they are made up. But later on with some of the research and the other information, that is all going to be based off of real information there as well. All right, so since this is a lot, we don't care about all of this. We only care about one little part of it. So which part do we care about? Well, just that part, because that part that I have circled or boxed in the red, those are going to be the LM and NTLM hashes along with the usernames. And we can kind of start breaking this down, get a little bit, look at it a little bit more closely to see what the various parts are. So if we kind of do a close-up, that's really about the only part of it that we care about. So when we extract this, CrackMapExec or any other tool is often going to give us that huge big file with lots of lines in it, and we don't care about a lot of the others. If I just go back one slide here, where you see just below that red box, you start seeing like the usernames with a $sign after that, and what that's an indication of is going to be a hash that is generated by the workstation itself. And one time I was lucky enough to see a clear text machine generated password, because I'd always been told, like, you're never going to crack a machine hash, so don't even bother. And of course, anytime that somebody tells you, like, don't even bother, you're never going to do it, you're like, well, maybe I'll give it a shot. Who knows? There might be a weak one in there. I'll get lucky. Well, one time I was able to extract the memory using Mimikatz. And one of the things that I saw in there was a clear text password that was one of these $sign machine hashes, and found that it was a completely random alphanumeric 256 character password. So yes, that is not something that I will ever crack, so I don't even try, which is why I'm going to leave out all of those $sign ones that they certainly are NTLM hashes, but I'm not going to be able to crack them. And everything else that's down below is just other types of hashes that, they're just slower to crack, and they're the same values as what I have up above. So I'm going to go after the easy ones. All right, so we have our close-up. We have the NTLM hashes, the parts that we actually care about. This is what we're going to do our work on, and this is what we're going to try to hash, so to crack. So what is everything in there? Let's break this down piece by piece and see what is in there. Just looking at the first line. So that first thing that we see, the administrator, well, that's the username. Quite often, the very first one that we'll see in there will be the administrator. Some places might deactivate it, might turn it off. There are ways that you can just kind of look at the hashes themselves and see if it has been turned off. Like, for example, the second line where you see guest, the guest username. And if you, each of the different parts are just broken up by that colon. So like you see guest 501 and then AAD3B. And then if you go a little bit further down, you see another colon and you see 31D6CF. Well, that 31D6CF is actually going to be the hash, the null hash for NTLM, which basically tells us that account has been deactivated. So sometimes we will see that 31D6CF hash for the administrator, and that tells us that the administrator account is not going to work and that hash, that password is null. So don't even bother with that one. In our instance, we see that the administrator hash for the NTLM value is that 64, which I guess I'm getting a little bit ahead of myself. You've got to go through each of these pieces individually here. That next part, that 500, the Windows relative identifier, the RID for that just kind of ways the Windows keeps track of each of these important usernames. So next is that hash, the first hash that we see in there, AAD3B43, blah, 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 blah. That's a LAN manager hash. We'll talk about that one a little bit more in just a minute and why we care about those sometimes. And then the last part is the one that we are going to be really focusing on tonight, the NTLM hash. That's 64F121. That's going to be the one that we are often really looking to crack. And we'll also explain a little bit about why we're focusing on the NTLM more so than the LM hash. So let's talk a little bit about the LM hashes. And again, the LM hash, whoops, back. The LM hash is that AAD3B4351. Okay, so we have two different hashes in there. We have the LM hash and the NTLM. So talking about LM hashes, they are like super old. A lot of times when I give this presentation in person, I'll kind of ask the group, when did Microsoft stop supporting, actually, I think maybe the better way to phrase this, when did Microsoft start supporting NTLM hashes, which were considered to be an improvement over LM hashes? So when Microsoft started supporting NTLM hashes, it was because they knew LM was not very secure, and we're gonna see exactly why. And scarily enough, we do still see active LM hashes in company environments. And if you want to kind of look back as to see when NTLM was added, it was added in 1993 with Windows NT 3.1. So it was around 1993 that Microsoft said, yeah, here's the alternative to LM hashes. Stop using those if you can. They do still exist a lot of times for backwards compatibility, and a lot of times now just because they kind of get missed, or because of this last step that we see here, that they should be disabled when they're replaced. And anytime that we see LM hashes in an environment, we tell people to stop using those, disable them. And sometimes when we give that advice, the response that we get is, well, we did disable them, so they're not going to work. But us as testers, we say like, well, they do still work, and we are still able to get information from them, which kind of baffles the system administrators. The part that they missed is, yes, they might have disabled the LM hashes, but they didn't do a password reset. It's after you disable, you have to do another password reset, which is then going to deactivate the LM hash. How can you tell if you have an inactive LM hash? Well, really easy. If you look at that LM hash and you see that AAD3B435B51, that is the null or disabled LM hash. That is a good thing if you are trying to protect your company. If you see anything other than that AAD3B435 as a pen tester or as a password cracker, you're pretty happy, because these LM hashes are super easy to crack, and we're going to see exactly why. All right. So about this, why do we care about these kinds of things? Well, because they are super weak. So the way that LM hashes work is the maximum password length is 14 characters. If you are supporting LM hashing and your password is longer than 14 characters, anything after 14 just gets ignored, just gets dropped. So it doesn't even matter what anything else that you put in to your password after 14 characters. To make things worse is that it's all stored in uppercase. There are no lowercase characters in LM. So we have just completely reduced the key space by 26 characters. Let's make it a little bit worse. What they do then is it's not even a 14 character password anymore. It's a 7 character password or less. Because what they do is they are going to break this up. If the password is more than 7 characters, well, they're just going to store it into 2 hashes and know how to keep them together. One thing that you can kind of see with that, I'm going to back up one slide with our AAD3B. If you kind of look through it, notice it repeats about halfway through. AAD3B435B51404 EE, and then look, AAD3B43. So that is how they break this password up, is they have basically 2 hashes that go together that make up the 14 character password. All right. So if you're going to only allow up to 14 characters and only allow uppercase numbers and special characters, no lowercase allowed, and if you are basically going to turn those into 7 character passwords, that is super easy to brute force. Using our password cracking machines that we have now, that is often how we are going to crack LM hashes is just through straight brute force. We are just going to try every possibility for uppercase, numbers, and special characters in each of the 7 places. And it goes super fast. Usually less than 10 minutes, you can crack an entire list of LM hashes. And the other interesting thing is, remember when I said in order to deactivate and make the LM hashes not work anymore, you need to change the password. So if the LM hash is still in there and it's not that null hash, that means it hasn't changed. That means the NTLM also hasn't changed, because if you change the NTLM, it's going to update the LM to the null hash. So if you're seeing an actual LM hash in there, that tells you that whatever the LM goes to also matches up to the NTLM, which makes cracking NTLM hashes even easier. So that's often where I start to get my kind of foothold on the cracking of all the NTLM hashes, by cracking the LM first, because I know that I can very easily brute force the LM hashes, and whatever that one is going to be the same for the NTLM. You know, I'm going to have to do a little bit of extra when I try to crack the NTLM, because there might be lowercase, but that's trivial. That's super fast. You know, if I know what your LM password is and all I have to do is start toggling uppercase to lowercase, that's going to go super quick. You know, there's no toggling for numbers, no toggling for special characters. It's just checking, you know, do I have an uppercase P? Well, now let's see, is it actually a lowercase? If it is, great. You know, that works. But that's super quick as well. Just to further drive this home as to what an LM hash format looks like, let's use password one, blah, 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 super long, super secure. It's got all 4. It's got uppercase, lowercase, numbers, special characters in there. That would normally be a really difficult password to crack. But if we were to hash this into an LM, it's going to be pretty easy, because remember the first thing, they break it down into 14 characters. So we see that it turns into password 1, password. Also, it goes into all uppercase. So that's where we're starting with it. And then remember, the next thing it does is it breaks it down into 2 7-character passwords. So now all we are trying to crack is that password and the D1 pass W. Makes it super easy, super fast to crack. So that kind of gives you an idea about why LM hashes are bad. All right, enough about LM. Let's move on to the NTLM stuff. If anybody has any, I'll take a quick stop just in case there are any questions at this point. Feel free to speak up. I don't know if people have the ability to unmute themselves and speak up, but.
Hey, Patrick, this is Adam. So I was just curious, what kind of system do you use for cracking passwords? Like, do you have one with lots of GPU power, or do you just kind of use more of a basic desktop? Or
that's a great question. Both. And I do have access to a machine that has, I think, 8 GPUs in it. So that is capable of going super fast when you put all of those together. And it really depends on what kind of impact that you want to show. Like if you want to be able to crack a whole lot of passwords in the list, then sure, you'll probably use something with like 8 GPUs. But I also sometimes just like to use a Kali VM, which is going to be super slow, super weak. And if I can go through and crack, let's say 50% of your passwords with a Kali VM, you probably have some pretty weak passwords in there. And to me, that often shows, you know, a much higher impact that somebody's able to do that with not very much hardware, and see that you have somebody's able to crack, you know, half your domain passwords with something that weak. When you have like 8 GPUs, yeah, sure, that of course you're going to be able to crack a whole lot of stuff. You know, the bad guys have that kind of thing too. But just like a Kali VM, cracking a whole bunch of your passwords is probably not a very good look. And one of the future slides, one of the pictures will kind of show some of the GPUs that we do also have access to.
Okay. And then if we're just kind of, playing around and learning stuff, do you think it's worthwhile to invest in hardware like that, or just run in a VM, or maybe if we want to do something a little more advanced but don't want to invest in the hardware, just getting something from like Amazon or some hosted service as just a quick, play around with more power?
Yeah, that's a great question as well. And I have a slide in the coming up that shows like the AWS cost. So once we get to that one, we'll see how much like AWS costs. I've been doing a little bit of the pricing myself because I don't have my own like GPU password cracking machine just yet. It seems like about the bottom end for like a super cheap machine might be around $1,000 to get like a 1 GPU small unit. And some of these things can very quickly escalate in price, $5,000, $10,000. So if you want to be doing dedicated password cracking, it's probably going to cost a little bit of money. It's probably not the kind of money that you're going to want to spend just for something that you dabble in. So if you're just trying to learn how to do some of the password cracking, I think just using a VM, a Kali instance is going to be perfectly fine for your use. Or sometimes even just using your laptop that has a GPU in it will be faster than using a Kali instance. Anything like that can sometimes work as well.
Thank you.
Anybody else have anything? Are we all good? Okay. All right, moving on. Most cracking is on that second part, the NTLM. There are a couple different, server software that you can use. People ask to use Hashcat, to use John. Either one works. You can certainly use, both are on Kali. There's password cracker, John the Ripper that's on there that you can use. But I just like to use Hashcat just because it was what I first learned and what was available. Both are free, both are available to install. Hashcat is available at hashcat.net. It definitely works better with a GPU. GPUs just obviously go faster. That's along the same lines of why people are using GPUs for their Bitcoin mining or for their gaming, just because they go faster. There's a great manual available for Hashcat as well at the wiki. And how does it work? This is kind of an interesting one that comes up from time to time when we start talking about password cracking and how Hashcat actually cracks them. And I think part of the confusion is also because of TV and movies. There are so many times when we see somebody trying to crack a password, or I think it might even been like, remember the movie War Games, if you've seen that, where they're trying to get into some kind of system and all the different digits are kind of spiraling around. And then the first one matches up while the rest of them keep spinning. And then the second one matches up and then the rest of them keep spinning. And then the third one. That's not how it works. The way that it actually is going to work is we're technically not going to decrypt them or deobfuscate them or anything like that. The way that Hashcat is going to work is we're going to feed it a hash. And we're going to tell it that this hash is type NTLM. So assuming that you get that part right, Hashcat says, okay, so you gave me an NTLM hash. If you want me to tell you what the clear text value of that is, what I'm going to do, me being Hashcat, is I'm going to take a word list. And you can get word lists anywhere. And word lists are often just kind of big lists of passwords, which you can find in lots of different places. Kali has a bunch of different word lists in there. I think inside of the user share word lists directory, you'll see probably about 10 or so word lists in there that you can use. And what they're going to do is take one of those word lists and they are going to just go right through and take the clear text word and turn it into an NTLM hash and then just compare the hashes. So if the hashes match, well, now Hashcat knows that it is that clear text value of that word that you took out of the word list. You can do a little bit more things with it. You can apply rules. So maybe you use that same word and then instead you kind of apply some other rules to it. So let's say you have a word list that has all lowercase words. So you pull up the first one and you test out the full lowercase word. Well, that one doesn't, once it hashes and compares the hashes, that one doesn't match. So maybe the rule says, well, make the first letter uppercase. So the next thing it's going to do, that Hashcat will make the first letter of the clear text word uppercase, turn that into an NTLM hash, compare the two hashes. And it's going to go all through the whole list and apply all the different rules that you want to use with it. And we'll see a little bit more about that as we go through. Here is how you can use Hashcat and some of the different switches and flags that you'll want to be using with Hashcat. So the usual, calling the Hashcat binary. And then the next thing is going to be the file containing your hashes, or you can even just put a hash right there. But if you have a whole bunch of hashes that you want to crack, you can put them in a file, make that the first command line argument. The next thing is the -m, or the mode, which is the hash type. And remember, on that documentation on the wiki is where you're going to find what that number is that matches up to your hash type. There's many dozens of different hash types that are supported by Hashcat. So you kind of refer back to that wiki. Once you know exactly what type of hash that you have, you can then find the corresponding number for Hashcat. The next thing, the A, is going to be the attack type. And that just 0 refers to a straight attack type, which means that it's going to use rules and a word list. There's lots of different other, I think about 7 or so different attack types that you can use. Like I think number 3 is going to do like a brute force attack using masks, where you tell it, like, check to see if the first character is uppercase and the next 5 characters are lowercase, and then finishes with a number. Is another type of attack that you can do. That W is the workload. 4 is going to be the most. In the documentation, it actually refers to it as a nightmare or insane power consumption. So if you do want to have your own password cracking machine, you are going to see electricity use differences depending on how you use it. If you want to just kind of fire it up with the W4, it's going to use a lot more electricity. But if you are using a server somewhere else, well, you're using their electricity. So yeah, go ahead and just use the maximum. Use that for. Uppercase O is an optimized kernel. It's just kind of some optimization that just makes things go faster. I don't really have details specifically about what the -O does, but it just makes it better. And then the R is going to be the rules file. We'll see some other rules that you can apply to your words. And that was there's many different rules that you can apply. Often your rules file will be hundreds or even a few thousand different rules. That's the thing where you tell Hashcat, make the first letter uppercase, make the first 2 letters uppercase, make the first 3 uppercase, or add a 1 in the front, or add the 4 different digits in the front, are all things that you can do with rules files. And then the last thing that you put in there is going to be your word list. And again, you can get word lists from Kali, or you can kind of find them on the internet, crackstation.net. I have some of these resources in here, and I'm happy to share the slides at the end. And I know Ray said she was recording this, so you can kind of get all this information from any of those places. But yeah, crackstation.net, I think skullsecurity.net is another place where you can get word lists from. And I'll also talk about some other places that we can get word lists in addition to. There's one other piece to be aware of when cracking these hashes, and that is going to be the Potfile. Potfiles are being used for efficiency. It makes no sense to crack a hash twice. So once your server has cracked a hash and it knows what the clear text is, it's going to put a combination of that hash and the clear text value into a file called a Potfile. And those are just kind of stored somewhere on your Hashcat server, or you can even indicate your own Potfile. And sometimes I will just kind of add a file at the end of that whole command that we had on the previous slide, which is a --potfile -path equals whatever the file path is. So you can, these are going to be just a clear text file. You can kind of look in there, and it is going to look exactly like you see that last line where we see the hash and then the clear text value. So as soon as Hashcat starts up, the first thing that it's going to do is it's going to check the Potfile, because it will read through all the hashes that you give to it. And if it finds any of those hashes in the Potfile, it's not going to bother cracking those again. And it will tell you immediately, removed so many hashes found in the Potfile, which is always kind of funny when you're cracking Active Directory hashes for multiple different companies. And the first thing it does is it tells you that it found hashes in the Potfile, which means it's the exact same password at 2 different companies, which isn't really surprising. You know, people aren't real original. People reuse passwords. So, all right, as soon as you run it and it gets going, this is the kind of thing that you see from the output, or at least when it finishes. We see that Hashcat is that session. It's what's going to be running. The status exhausted means it's all done. Next thing is it's showing you that hash type. Well, we set it to be that M of 1000, so that's the NTLM. The target is going to be either one specific hash or a whole file of hashes. And then it also shows you when it started and when it finished. So this whole thing ran for all of 2 seconds. And we'll see some statistics on this as well. Next, we see the word list. I used RockU. The rules, there's this one rules file that comes with Hashcat that I like, the Inside Pro rule. There's 2 different Inside Pro rules. I'll often use both of them, but there's a few different rules that are good to use. Then we start seeing some of the speeds. This one has 4 GPUs, and we see that each of the GPUs is running at almost 6 giga hashes per second, or 5,976 million hashes per second that it was checking on that single GPU. And they are all combined. So we see down when it combines them, basically 23.5 giga hashes per second is what this thing was going through. So in 2 seconds, if we look down a little bit further, let's see, where is the full number? Oh yeah, I think it's the progress. That 4475590, that's the number of hashes that it tested. So let's see, how many numbers is that? 920, 903. So it looks like that is thousands, millions, 44.7 billion hashes were checked in 2 seconds by this machine. So that's kind of how fast this one goes. And this is not any kind of world-class password cracking. This one's decent. It's got 4 GPUs, but lots and lots of people have better things than this. So this one's okay. It certainly serves the purpose. It works. But also more interestingly, if you see that line that says recovered, that shows the number of password hashes that were cracked. It found 12,523 unique hashes in the file, which is another kind of heads up for you. If you do like a WC on your hashes file, you'll have some number of lines of in your hashes. And when you see that recovered, that denominator there is always going to be smaller than the number of lines that you actually have, because that 12,523 is unique hashes. We know that there are going to be some passwords, some hashes that get reused. So again, Hashcat is smart enough to not crack the same hash twice. And we also see that in that 2 seconds, 3,234 passwords were successfully cracked, or nearly 26%. So that was just one pass that we went through with this, with one word list, one rule set. And we have lots of different options, lots of different word lists, lots of different rules. We can swap them around. We can try different attack types, all different things in order to just keep building on that list of recovered passwords. All right. So I think I went through each of these kinds of things without clicking the slides. So I'll just kind of slowly show that again with our 23.5 giga hashes per second and our nearly 26% recovered. Oh yeah, I do have the dots in there to show the 44 billion that were checked. All right. One of the most common questions that when somebody first starts is if they send some hashes through Hashcat and this is the output that you get where it just says exhausted, like where are the cracked hashes? Give me the information. You said that you cracked 3,200 passwords, show them. I want to see the clear text passwords. Where are they? It's kind of it's an extra step. So here's the extra step. So you run it again, you know, hashcat minus M1000, you tell it that they are NTLM hashes. And you also give it the hash file again. But now instead of all that other stuff, you tell it -- show. And what show is going to do is it's going to show you the clear text password. And what if you want to see the usernames, that's totally optional. If you want to match those two things up, you can give it -- username. So we can kind of see when we cracked some of these passwords here, let's see, that guest, you know, I kind of mentioned that 31D6CF, that's like a null password. It's blank. There's nothing to that. Next one, Jar Jar. Well, he has his own password. He's not too bright. The administrator, password 1. Let's see. Next one, Ben. His password, Master Yoda, Vader, Lord Vader is his password. And then Luke, his password is the Force. So that's after you do the cracking, how you can get your data back is going to be with -- show. Another way that you could do is just go look in the Potfile, but you know, the Potfile is going to have all the hashes that have ever been cracked on that machine. So you look at the bottom and it does just kind of append to the bottom of the file. So whatever is the last time that you ran through, you'll see them all there. Or you can kind of do it this way with show. Question about the cost. So I kind of mentioned that if you want to buy your own machine, about $1,000 might be about like the super cheapest bottom end that you can go for like a dedicated GPU password cracking machine, all the way up to, you know, 10, 15, who knows how many thousands of dollars that you want to spend, depending on, you know, how much RAM that you want, how many GPUs you want, what kind of cooling, all that kind of stuff in there. Or you can go up to the cloud. So Tinkersec, I don't know how many of you are familiar with Tinkersec on Twitter. He's a great guy, super smart, always sharing lots of information. So he wanted to kind of figure out, what does it cost for a password cracker on AWS? So he tried it. And what he did was he set up, it looks like an 8 GPU password cracking Hashcat machine on AWS, gave it a whole bunch of NTLM hashes, and he was able to go through brute force every 8-character password, which is all upper lower number symbol passwords, in about 3 hours and 10 minutes, which he said costs, I guess, a little bit more than $75. So you can kind of start figuring out what is going to be the cost that makes the most sense for you. You know, how many times are you going to be doing this at $25 an hour versus getting a $1,000 machine or a $5,000 machine? You know, you kind of look at it that way. So there's just kind of an idea of what some of those costs can be. I don't know if he's done a follow-up on that kind of thing, but I think he did this. This tweet is from a little more than probably a year and a half, maybe 2 years ago. And I've been told that the costs have come way down. So I have not seen that he followed up with this and tried it again. But I suspect exactly what he tried here is a lot cheaper now, or maybe even faster for the same price. So that's something to think about. All right, so we looked at the basics. What else can we do? What other things can we kind of switch around inside of Hashcat? Well, different things that you can do, different word lists. Where do you get some of these word lists? All over the place. Kali has some of them built in, like RockU is in there inside of user/share/word lists. LinkedIn had a major dump a bunch of years ago of their MD5 hashes, which lots of people have then reversed them into their clear text. So that's like many millions of clear text passwords that you can use as a word list. Crackstation.net is another place that you can get like this mega file with clear text passwords. But my favorite word list that I like to use is actually the Potfile, again, because people are not original. One of the things that we do see is that people don't change their passwords very much, and people don't really think of real original passwords. So the Potfile seems to really work for me. And remember that the Potfile just contains that hash and clear text of previously cracked passwords. So one of the things I'll do is I'll go into the Potfile, I will just grep out the clear text passwords, and I'll make those into a word list. Throw some words, throw some rules against that, and it then cracks usually at least a few more. Hashcat comes with a few different rule files, but you can also find some other good ones on GitHub as well. You can start looking at patterns. One of the things that I'll do after doing some cracking for a little bit is, I'll do the show and try to see if we can start spotting any patterns. Once in a while, we can spot some patterns. And one pattern that stands out a lot will be the first password that a company gives to somebody, or the password that the help desk does on a password reset. For example, recently, I think it was like 2 uppercase letters and welcome. So one of the things we kind of figured out was like, well, what they're probably doing is just doing the person's initials and sticking that onto welcome. So one of the things that we did then was, well, let's just tell Hashcat to check all 26 characters uppercase twice and welcome. And then we got a few more that way. I've seen other times where there'll be the company name will be in there with numbers after it. And a lot of times that works for like franchises. And sometimes you'll get like location numbers or store numbers. I'm just picking a company out of the cloud, like McDonald's. So let's say that you somehow got McDonald's hashes. Each McDonald's location has its own franchise number. And a lot of times there's passwords in there, administrator passwords, things like that, that are just set to whatever the franchise location is, franchise number is. So you can kind of just brute force through those. So maybe it's going to be like 6 numbers and McDonald's. So you can tell Hashcat to look for that kind of thing as well as some of the analysis. All right, where do you get some of these lists? Well, there's lots of leaked lists out there. I mentioned Skull Security. I think it's skullsecurity.net has some of those. Daniel Meisler, he's on GitHub. I think it's called SecLists is his project on GitHub. He has a bunch of passwords lists in there as well. Hashes.org, CrackStation. The Hacker Playbook is a book. It's a couple editions of the Hacker Playbook. And in the last edition, I think it was Peter Kim is the author, put together, I can't remember whether it was LinkedIn or one of the other recent password dumps. He put that list together as well. So I kind of pulled that one out there. Rocky is a big one, LinkedIn, the big one. Paste sites, I really like scraping Pastebin. There's always going to be various dumps there, but how do you kind of find them? Well, one of the ways that we do that is with Check My Dump on Twitter. And I'll show that to you as well. It's kind of neat. It's a Twitter bot that is always scouring Pastebin for what looks like password dumps. And there's also HavelBeenPwned, where they have password lists on there as well. And notice the title of the slide, I'm not calling them really word lists anymore, calling them password lists. And that's actually for a reason. It's super easy for us to just kind of put together word lists. And a lot of times, when we think about weak passwords, like, oh, children's names, pets' names. So let's just kind of put together a list of those kind of things. Like, yeah, those are good. But really what we want, what seems to be better in all the research that has been done, is these lists are better and more successful if they're actual clear text passwords that people have used. So that's going to be something that you would rather be using in order to be doing this password cracking, to use actual passwords that have been reversed previously instead of just throw the entire English dictionary at it. That's not going to be very efficient. Actual password lists are more efficient for this kind of thing. All right, looking at Check My Dump, if you've never heard of that. It's a bot on Twitter. And if you follow it, you'll see this in your stream where it tells you how many new credentials are found, and it actually gives you a link. So then when you actually go there, sometimes it's good information. Sometimes it's garbage, but it is a bot, so it's not super smart. But sometimes you get some good information. Like here's one example. This was something that I found on Check My Dump. And these were all just, I have no idea where they came from. Maybe that is the person's password for that address, or maybe this was some gaming service. I have no idea what it was to. It's extremely tempting when you see some of these kinds of things, since they're all email addresses, to be like, I wonder if that's the person's email password. It's super tempting to go to att.net and type in diane.ball@att.net and see if her password to get in is Natalie16. If you do that, you're breaking the law, so don't do that. The only thing that I ever use these kinds of things for is I don't even care what's before that colon. I don't care about their username. All I care about is their passwords. So anytime I find these kinds of things, that's what I do, is I just kind of download the whole list, grep off of that colon, and then take whatever's after that colon, put that into my next list as well. All right, let's see here. Nick also, go ahead.
Just a quick question on that. Do you ever take like this dump file and run it through Hashcat to build your Potfile, or do you just add it to your password list?
I just add it to my password list. And one thing that I had been doing for a long time was just anytime that I scraped this, I would just add it to my word list, because the Potfile is has to be for the Potfile includes, remember, the hash and the password. So if I was going to add like Natalie 16, I have to go create the hash for that, which, yeah, that could work. And if I want to go create NTLM hashes for all these, that's perfectly fine. And, you know, that's something that you can do. But instead, I just add these to a word list. And then, you know, every so often we'll use that word list with different rules and see if any of those things are going to crack as well. Yeah, that's a good question, Trevor. Nick was saying that he finds good use of NetMux's hash crack book. As in that book, it also has specs for a $1,000 cracking setup and one that is $4,000 to $5,000. Agreed. I also have that book somewhere in here in my mess. But yeah, the name of the author is NetMux. I think he might be part of Team Hashcat. I'm not totally sure if he's part of the Hashcat team, but he did write a book on password cracking, and it is called Hashcrack, where he has a lot of it is going to be kind of looks like documentation with all the different switches and various things that you can do with it, but there is other information in there as well. But NetMux also has a couple blog posts about different password cracking setups and specs that you can use. And I agree that those two posts are great. The one that Nick mentions that's $1,000 is actually like a tiny little box. Based on what I saw in the pictures of it, looks like it's probably a maybe like 8-inch cube, where he says that this is really great for pen testers to kind of bring with them to like on-site jobs, because it's like such a small little server versus some of those $5,000–6,000 ones, which you're not going to travel with those, and they're going to be a pretty big setup, use a lot of electricity kinds of things as well. But yeah, NetMux is the person that wrote the book. He has got blog posts. His book is Hashcrack. I like it. It has good information in there as well. Rules, I kind of briefly mentioned what rules are going to do. They are, if we don't assign rules to our cracking session, then one of the things that you'll see is your cracking session finishes super fast. And it's like, okay, something must have gone wrong there, because there's no way that this whole thing went through and checked everything in like half a second. And a lot of times I notice it's because I forgot to add rules. And if we don't add rules, what Hashcat is going to do is it is only able to check literally the clear text password in the word list. So if somebody doesn't perfectly match up exactly, exactly by case what's in that word list, then it's not going to match. And this is really going to be where the power of the rules come in. And Hashcat comes with a few rules. There's other rules that you can download from like GitHub and add to your instance. So some of the rules that might change like password into password 1, or you can tell it to go from password 01 to password 9999, or leet speak it, change password into P $$W0RD, or even drosap it, reverse it. It just kind of took password and put it backwards, maybe even double it up. One of the tricks that I really like when companies start going with longer password requirements, I remember one that I did one time and they thought they were pretty secure because their minimum password length was 15, which that is a pretty long password, and that's not going to be super easy to crack. But one of the things that I noticed was that what their employees were doing was just doubling up shorter passwords. So I did actually see some things like password, and it was, it meets it. It was more than 15 characters long. It had uppercase, lowercase, and maybe they threw an exclamation point at the end or something like that, so they could have 3 out of 4. But that was one of the things that I noticed when companies started going for longer passwords, is that people are going to try to find ways around those. All right, so some of the more common patterns that I see, like I mentioned, I get hash lists from other people on my team, and I do a whole lot of cracking for them. So at one point, I think I had cracked a couple million passwords, and I had kept all those files separate so I could kind of get an idea of statistics on each. And then one of the other things that I did with it was try to figure out if there was any kind of commonality with how the passwords were actually set up. And it turned out there were. These were the top 10 password patterns. And when you're looking at this, the U is uppercase, the L is lowercase, the D is a digit, and the S is a special. So the thing that I found in my research, I don't know if it was 1 million, 2 million passwords, was 953 of them followed this first pattern of uppercase, then 5 lowercase, then 2 digits and a special. And you can kind of go through and see each of those all the way down to like that 9th one, which is all lowercase characters. I think that's 9 lowercase characters. So a lot of times, this is another thing that I'll do is I'll kind of just pull these out and throw this at a hash list as well and see how many of the hashes that we can crack using these. Because again, people are not too original. I'm guessing anybody listening to this, if you think about all the passwords that you have, chances are at least one of your passwords has, the first character is uppercase. That's pretty common. If you're used to cracking passwords, then maybe you don't do that kind of thing. But the huge majority of the time when you look at cracked passwords, the first character is going to be uppercase. So that's usually where I'm kind of starting with those kinds of things. What the rules, what these patterns are going to translate into are called masks, M-A-S-K. And you can give a mask file in place of the rules. So here I used kind of dashes to separate them. But when you create a mask for Hashcat, it uses the question mark. So what this would be is question mark U, question mark L, all the way through. And that is going to generate or be the equivalent of a mask to Hashcat. So once Hashcat sees that, it knows to check for the uppercase, lowercase kind of thing as well. So masks are something else that you can use in addition to rules. I also mentioned analysis. How do you do some of the analysis and look for these patterns? Well, one tool that you can use for that is Pipal. This is a tool that was created by Robin Wood. Robin's awesome, creates so many great tools. So you can find this at digi.ninja/projects pipal.php. And what you do is after you've been cracking a whole bunch of the passwords and you get the clear text, create a file with just the clear text values. Don't put any hashes or anything else like that in there. And you run Pipal against that. And it's going to, by default, show the top 10 of these things, passwords. Base words. What's a base word versus a password? Well, if you have people that have password 1, password 2, password 7, password 25, well, the base word in that is password. So it's really going to be able to show you the lack of originality. More lack of originality might be the company name. So I work for Rapid7. We might have a lot of people with like Rapid7 December, Rapid7 January, Rapid7 Spring, and then the base word for that is obviously Rapid7. You can see various patterns that might be coming up, and it's going to show that through masks. It'll show the top 10 masks. It'll also tell you the top 10 password length. And one of the things that I see is that the vast majority of time, the most common password length is whatever the minimum is. So if your password minimum length is 8, then very commonly that's going to be the most common password length in the whole list as well. Pipal can also show you the common character positions. It'll show you, how many have first character uppercase, how many have first character lowercase, how many have first character special, all that kind of stuff. So Pipal can do a whole lot of analysis as well. Let's see. HavelBeenPwned, mentioned that one as well, which is another great place to get data from. They did also release the top 1 million MD5 password hashes that they had seen. So I just kind of took those and decided to crack those a little bit. And here were some of the statistics using Pipal against the HavelBeenPwned top 1 million password hashes. We see These are base words instead of passwords, so there's probably even more of them in there, but they do still seem a little bit low. You know, it kind of is probably not surprising to anybody to see some of these words in there for common passwords. Let's see, more Pipal data on the HavelBeenPwned password length. And a lot of times that is because 8 is, for some reason, an extremely common password length. And I think 8 is the extremely common length because at one point, the industry had decided that a password length of 8 was going to take too long to crack. And by too long, it just meant like centuries. And that was because that's where the hardware was at the time, and pretty much people didn't change too much. So I think that's why 8 is very commonly the minimum length that is going to be used. All right. Let's see. Oh, also, this is kind of a fun one, the last digit. Obviously, 1 is by far the most common. People just love to throw a 1 at the end of their password. 3 is the second most common. That seems a little bit weird why it would be 3, and that's just because people like to throw 1, 2, 3 at the end. The other one that you'll very frequently see as a common last digit is whatever the current year is. So right now, 0 is probably slowly moving up to the list. I would bet that 9 would still be a more common last digit than a 0, but by the end of the year, the 0 will kind of climb up there and pass it. Last 4 digits, looking at these, well, 1, 2, 3, 4 is the most common that they see. 2, 3, 4, 5 is the next most common, and that is because we're looking at the last 4 digits, not the last 5. So chances are the last 5 digits were 1, 2, 3, 4, 5. And then you also start seeing some years, 2010, 2008, 2009, all those kinds of things as well are common last 4 digits. We're seeing not a lot of originality from people. And then I also did figure out what is going to be the most common masks from these top 1 million passwords. All digits was about 8.5%. All lowercase, 2 digits, almost 7%. All lowercase, 6.5%. So it's just kind of fun to do some of these types of analyses as well. You know, like I said at the beginning, my hobby is cracking passwords, and that's pretty nerdy. I understand, but this is the kind of stuff that I just like to do. All right, so we get into some of the bonus material now. You know, I added bonus material for times that I give this presentation and they have the hook to pull me off stage or not. I'm guessing Ray's not going to pull me off stage. So bonus material, what are what are the 3 most common passwords? I can't really interact with people, so I'm going to have to just kind of go through it and tell you with these. And I actually wrote a whole blog post on the Rapid7 blog site about if you are able to eliminate these 3 passwords from your users, you're going to make my job a whole lot harder, because these are the first 3 passwords that I look for. Sometimes when I'm trying to get a foothold in a network, I'm trying to get any kind of access, these are the passwords that I'm going to be guessing with because they very often work. And for a little bit of a hint, I like to look at the password policy. The password policy kind of helps us to understand why people use at least 2 of the 3 most common. So in a Active Directory environment, this is an extremely common policy. It's actually not very common that they're not using this policy. This happens so much. Minimum 8 characters. We want you to change your password every 90 days, 3 months. You must have at least 3 of these 4. You must have at least 1 uppercase character, at least 1 lowercase character, at least 1 digit, and at least 1 special character. So based on this, the very typical things that people use for their password, well, the first thing that most people are going to guess is, well, password. Yeah, password is still an extremely common password, but it's variants. It's not too often that somebody's just going to use an all lowercase password. If they're using that, they're really not trying too hard. We might see some other variants with, you know, the @ sign, $signs, and those types of things in there, and they think they're being really smart and outthinking us, but no. But the other one that really is the hint in there is going to be that making people change it every 90 days. Because when you start thinking about what other things change every 90 days, you start thinking of the seasons. So the seasons change every 90 days. So every time somebody has to change their password, it's like, okay, what's the season in the year? And that's going to be the next one that people often go with. So right now, as pen testers, when we're trying to get into networks, we're probably going to be trying lots of variants of Spring 20, Spring 2020, Spring 20 exclamation point, Spring 2020 exclamation point. And then once we've exhausted those, we will go back and use like Winter 2020, Winter 20, Winter 20 exclamation point, Winter 19, because those are so extremely common. And if you are able to have enough guesses without locking somebody out, then you're probably going to get at least one user with those. So what's the third one? Well, it's always going to be some variant of the company name. Every time that I crack these hash lists, we do see guaranteed at least one of these. We are guaranteed to see at least one of a variant of password or the company name or the season year. Extremely commonly, you get 2 of those 3, and also a lot of times we do get all 3. And even worse, all 3 are often in the top 10 base words. Auditing, if you want to do any kind of checking, instead of cracking your people's passwords, you can kind of do it in reverse. Do it the same way that Hashcat does it. Figure out what are going to be some of these common passwords. Like maybe you figure out like summer 2018 or spring 2020, and then put it into the hash version. Look at all your password hashes and just match them up yourself. You don't have to reverse. You don't have to do the password cracking to do that. You're doing the same thing. So if you can go online and there's lots of like NTLM password hash generators. You just give it the clear text and it'll give you the NTLM hash. Grab a few of those, start grepping with them against your NTDS file, and any matches in there, well, you just guessed that person's password, and it's probably pretty weak as well. All right, another bonus thing that you can do. Pull out all your domain administrator or enterprise administrator hashes. Okay, these are all your privileged people. These are the people that should be choosing extremely strong passwords, things that aren't easily guessable. And you also separate them to have their domain administrator account. So you can kind of separate the privileges so that they are only using their domain administrator or enterprise administrator account to do very specific privileged things. For everything else, like surfing the internet, checking email, they should be using their regular domain account. So what we're going to do is also pull out their personal account hash. So once you have their DA hash and you have their user account hash, you see where this is going? Are they the same? And I would say anytime that I do this, probably half of the DA users are using the same password for both. And then once in a while, when you get lucky and you start cracking all of those, a lot of times I do just see variants. Whatever that person's user account is, their DA password might just have a 1 at the end. It's like, okay, I guess that's different enough, but I don't like it, but at least it's different. And at least the hash shows that they're different. But if you can pull out somebody's DA hash and their user hash and they're exactly the same, that's a conversation that you probably want to have with people. Lastly, if you want more information, I mentioned some of the blog posts that I've written, so you can kind of check some of those out at the Rapid7 blog site, where I talk about some of those masks that I created and some of the statistics with those as well. Figuring out what is the company's default password is sometimes fun to go after as well. Let's see some of the different patterns that we might see and those 3 passwords to eliminate. So if you want to read a little bit more of some of the research that I've done, that is all there. And if you want to get in touch with me, there's my email address and my Twitter handle as well. There's another place that you can kind of check out where I am for that kind of thing. So that's what I got. Any questions?
Nope, no questions. You can't hear me, right? I switched headphones, so okay. All right. Well, thank you, Patrick. This is great because the club does the National Cyber League like twice a year, and I think a lot of this will be helpful to people who play those games.
Excellent. Yeah, when you start getting some of those hashes that you either pull out or they give you and then crack them and figure out how to use them.
I'm never good at that stuff. All right. Well, thank you, everybody, for coming out. Thank you, Patrick, for joining us tonight.
And everybody have a good night.
Thank you.